Welcome to another Hopper on microcontrollers video. Hopper is a modern curly brace and semicolon language, a little bit like Java or C#, in other words, garbage collection, C-like language, but it's designed to run on small devices. I recently added NeoPixel RGB pixel RGB LED functionality to the library. I used Adafruit's library for this because I build the library on the Arduino environment. I build the firmware on the Arduino environment, so you don't have to, and they've got a good library. That's built into these UF2 files, which you just drag and drop onto your RP2040 device. All of these devices that are on my desk right now here are RP2040 devices, so they're like Raspberry Pi Picos or Pico Ws. This one here is something called the Challenger from a Swedish company, and it's actually got Wi-Fi on it as well, but it's not the same Wi-Fi controller as the Pico W. So this is more like a Pico with a ESP8266 Wi-Fi chip on it. Since I am benefiting from Adafruit's development, I've got one of their boards here. This is a pretty neat board. I'm starting to get quite attracted to it. It's like in the old Arduino Uno format. And I have another board of theirs. It's in the feather form factor. Like I said, these are all Raspberry Pi RP2040 boards. They've all got the same microcontroller on them. And another thing they all have in common is they all have USB-C sockets, which I far prefer. And they all have little RGB LEDs on them. That's what these little white things are, the one in front of my thumb here. So most of them have something that looks similar to that little white one. This one looks slightly different on this Sparkfun board. It's right at the end there. That there. Anyway, let me switch to. This gets baked into the Hopper runtime, which you just drag and drop onto your device, and you'll get the drivers already working, everything as it's supposed to. So what we've been watching here is it's running in the debugger right now. So on the serial port, it's putting R, G, and B whenever it switches the color. So I test by checking whether I've got R, G, and B, red, green, and blue correctly configured. And then, I run around in circles. Like this is a sample called Blink RGB, which is included in the GitHub repo. I'll have a link to the GitHub repo. I'll have a link to the Adafruit library use in the description. So if I Control C, I always like showing off the fact that this is different to developing on Arduino, in that I can F10 through here. So I'm going to set the next pixel, the current pixel, to green. It's already green. Now we're going to set it to blue, and now we're going to set it to black. And now so you can see it changing on the screen there. Let's say we set it to red and show it, and write R and delay, and set it to what's that, blue, green, and then blue. So because this particular device has an array of pixels, it's got a matrix. It's called the Waveshare RP2040-Matrix. It has 25 pixels on it, so it's looping between them. Most of the boards just have like a single built-in pixel, but this one's kind of interesting in that it can step through these. So let's demonstrate a different one and show how this works. So I'm Control C out of this and get out of there. Let's unplug this one, put it aside. And let's plug this one in. So that's the Metro from, and it's already got the program running, but I'll build it anyway. So if I need to choose a different, so this is the Adafruit Metro, and then I just F7 to build, Visual Studio keys, and then F5 to run. It starts by the bottom of the screen uploading the new program and break. It stops whatever's running. If I hit F5, it'll start running now. We see red, green, and blue flipping around there. It's a little faster now. There's only a 500 millisecond delay. Previously, there was a longer delay. And let me show you where with recent changes, I put all the drivers in actual Hopper code so that you could add your own here if your board isn't included or covered. So if we go into Microcontrollers folder here, there's now a NeoPixel unit in here, and it only gets included for devices that have a NeoPixel. And giving credit to Adafruit here for a little bit of their source code. And these are the functions you can use on your on the NeoPixel. So you can have a string of NeoPixels. So like you could buy one of these from Adafruit and use this library to light them up. So it's got more functions than what's just used to blink it in the blink example. For the blink example, I made a little helper function called built-in so that you could go and look at the source here and see how it's used. So how we initialize and set up, this is how you set up the device or the RGB LED. And some of them are more peculiar than others. So this is the one we've got now, the Metro. So it's going to define which pin it's on. Which pin is because it differs in the different devices. There's no standard on which pin is used. Yeah, and then initializes it, and there's no standard on what the color configuration is. They're not all the same. So the RGB versus GRB, and none of the ones I have white in them. Actually, I haven't really. I should check that. I haven't checked them all. I should check for white. Yeah. And so there's a combination of how the data is stored, and that's how you configure it. So I'll keep adding to devices as they come along. Anyway, let's look at one more. So this one's kind of peculiar. It's the Seed Studio one. So what's different about it? Let's go and change to Seed. And there we go. We're running a little faster now. Red, green, and blue flicking through. Now, what makes this device slightly different is it didn't just work, and I needed to go and do a bit of digging to find out why it wasn't working, even though I had the correct pin. And the reason was, and I found this in a sample on their website. I think I put a link to it. Yeah, I put a link to it. They've got to turn a power pin on. So I don't know why this is like that. You can turn, in addition to, setting your brightness or your colors to nothing, they have a second pin 11 and pin 12, and they use pin 11 to actually turn it on or off as well, which is unique. I haven't seen that in any of the others. Anyway, that's the long and the short of it. Like I said, these Challenger boards are kind of interesting too. The one with the Wi-Fi, I think let's have a look. I've got it loaded up on all of them, so it should just start flashing. Yeah. And I'll do more on this board once I set the Wi-Fi up. But that's how you find and set up your RGB LED. So to get it working, you call that built-in helper function that I created, and then you just set the color and show it. There's 3 lines of code to make these pixels, to make these work, and you don't have to configure anything. There's no configuration in here. You just have to pick your board. All right. Thank you for watching, and look forward to your feedback.